Hello. In this explainer, we're going to take a look at the book Formal Methods, Foundations, and Applications. If you're an engineer and you're curious about what this book covers and how it's all laid out, then this should be helpful. The idea here is to just walk through its structure so you can get a clear sense of its purpose.
All right, so here's our plan. We'll go through 5 main sections to really map out the book. We'll start with the why, the purpose behind it. Then we'll cover who it's for, take a tour of the actual content, and talk about a few different ways you could approach reading it. And to wrap up, we'll look at what you can expect to walk away with.
So let's start with the big picture. What's the main goal of this book? Understanding the why behind it is really the best place to begin.
At its core, the book aims to bring together these 4 key areas of formal methods: specification, model checking, theorem proving, and program verification, into one cohesive introduction. It's really designed to bridge the gap between abstract concepts and their practical application in software development. Okay, so we know the purpose. Now, who is the intended audience? Is this book for you? Let's take a look at the kind of background and goals that would make this a good fit. You'll see it's really aimed at practicing engineers and computer science students. So whether you're designing system architecture, working in QA, or building critical systems, the content is geared toward anyone looking to add more precision to their work. And what do you need to know before you start? Well, the prerequisites are pretty accessible. And this is a really important point. You don't need to be an expert in advanced math. The book is designed to build those necessary concepts from the ground up. All right, we've covered the why and the who, so now let's get into the what. The whole book is structured in 4 main parts, and they follow a very logical progression. You can see the flow right here. It starts with foundations, which makes sense, then dives into specific methods. After that, it covers how to verify your work, and then it wraps up by talking about how to put it all into practice. Let's just quickly peek inside each of these parts. Part I really sets the stage. It answers that fundamental question: why should I care about formal methods in the first place? It's all about building that bridge between mathematical theory and the actual code you might be writing day to day. In Part 2, things get a bit more hands-on. This is where you'll get introduced to a few different specification languages. Think of things like Alloy or TLA+. Each one gives you a different approach and tool set for modeling a system. Part 3 then shifts gears over to verification. So once you've specified a system, the next logical question is, right, how do you know it's correct? And that's what this section is all about. It gets into techniques like model checking and theorem proving to help you answer that question. And finally, Part 4 is where theory meets reality. This part tackles the practical stuff, like how does this actually fit into a real development cycle? What tools can you use? It also walks through some case studies, so you can see how it all comes together in the real world. Now, what's really nice about how this book is set up is its flexibility. You don't necessarily have to read it straight through from page 1 to the end. Depending on your experience, there are a couple different paths you can take. So, if you're just getting started with formal methods, the suggestion is pretty simple. Just start at the beginning. Go through the introduction and Part I first. That's going to give you that solid foundation you'll need before you jump into the more specific methods in Part 2. But maybe you're not a newcomer. Maybe you've heard about TLA+, and that's specifically what you want to learn. Well, you can just jump right to that chapter. The book is structured so you can always refer back to those early foundational chapters if you need to fill in some context. So at the end of the day, after you've spent some time with this material, what are the key takeaways? What skills will you have? Let's talk about the expected outcomes. The goal here is really to get you to a point where you can do more than just talk about the theory. You'll be able to compare different languages, you'll get some practice writing small specifications yourself, and maybe most importantly, you'll start to adopt this kind of rigorous thinking in your work. And that is our quick tour of formal methods, foundations, and applications. Hopefully that gives you a much clearer map of what's inside, from its purpose to its structure. We'll leave you with this final thought to consider. How might you bring a little more of this rigor into your next project?